Hi guys. So today's video is really just a review of Algebra 2 stuff and some Algebra 1 stuff. So we're going to look at what functions are in general and also what linear functions are. So to start, we're just going to say what a function is. It's something you spend a lot of time with in Algebra 2, but in case you've forgotten, not every graph that you see or every list of numbers that you see is a function. What distinctly makes something a function is basically every input has one output. If you put something in, you get something out. You don't get more than one thing that comes out. So every x has one y. So your y's don't repeat. You may, and you can pick any of these phrases that you want. So you may also remember the vertical line test. And what the vertical line test was where you could draw a vertical line anywhere on the graph, and as long as it never touched more than one point, then that graph was a function. So let's look at these first examples down here. All right, so in order to determine if this is a function, we're just going to see, do any of these y's repeat? So looking at this first one, every x has exactly one y. So yes, this is a function. All right, looking at the table. Okay, again, this time we're looking at it a different way, but each x only has one range coming off of it. So remember, domain is x's and range is y's. So again, that is a function. However, if you look at C, this fails the vertical line test. If I draw a vertical line somewhere on this graph, it touches more than one point. Since it fails that test, this is not a function. Okay, because again, every x, some x's have more than one y. All right, let's try again looking at the table. All right, so if I look, those x's have two different y values. The x's repeat. Okay, so those x's have more than one y value. And I just realized that I wrote y's don't repeat up here instead of x's don't repeat. Sorry about that. But every x has one y. Your x's don't repeat. It passes the vertical line test. All right. So again, I've got right here, it doesn't pass for two reasons. Okay. Again, I have two values there. If you're not sure, again, looking at the numbers as well, I could graph this. Okay. I could plot 0, -4. I could plot 1, -2, 2, 0. And then I could plot 1, 2, and 0, 4. And you could see that graph again fails the vertical line test. So this is not a function. So the other thing that we're going to do is we're going to list domain. So if you remember, domain are the x values in that function. So we'll start with interval notation. So that's what you spent most of Algebra 2 using with the parentheses and the brackets. So domain on a graph, we're going to look left to right. So the farthest left on this graph that we go is this point right here, which is at -7. Because it's a filled-in circle and actually touches that point, we're going to use a square bracket on that number. Then this graph goes all the way over to 2. It doesn't actually touch 2. That open circle means it gets as close to 2 as it possibly can, but it doesn't actually touch it. So that would be our domain for the first graph. All right, for the second graph, that one's pretty easy. It tells you the domain. It's the x values. I'm just going to list them because this is kind of that discrete set. If you want to put them in some brackets, you can. But again, we're just listing the values in that case. All right, let's look at this next one. The farthest left that this graph goes, so the farthest left is -8. It's an open circle, so it gets a parenthesis. The farthest right that this graph goes, well, it keeps, that arrow there is going to keep on going all the way to infinity. So this is going to be all the way to infinity. All right, again, in the next one, we're just going to list those x's. The only x's that I have are 0, 1, and 2. And again, the x's repeat, so it's not a function. All right, let's look at a couple more. All right, so again, we're looking at some ordered pairs this time. So again, let's see if any x's repeat. So I've got, let's go ahead and list our domain. There's 0. I'll list it in order, and that's 1, 2, and 3. Those are all the x values that I have. None of them repeat. So yes, this is a function. All right, let's look at f. It's really close to being a function, but if you notice right here, that x value of 1, 2, I can't tell if that's 3 or 4, whichever one it is though, that x value does repeat. There are 2 closed circles, which mean that this graph is not a function. Even though it's just one x value that repeats, it is still not a function. Domain here, again, we're going to go left to right. So the farthest left this goes is negative infinity. Then it keeps going until this point. But if you notice, it picks right back up at that same point. So even though it kind of stops there, it does include every single x value. So this domain is actually negative infinity to infinity. All right, going to our next one. Again, we'll look and see, does every x match up with one y? So negative 2 only has one line coming off of it, but negative 1 has 2 lines coming off of it. That means this is not a function. Again, domain here is pretty easy. We'll just list those x values. All right, and then finally this last one. So we're going to talk a little bit more about this next class, kind of see what you remember from last year. If you want to graph this, you can graph this. But yes, this is a function, okay? You can plug in every x value, and you can't repeat any x's, okay? You're only going to be able to plug in those x's one time. Now, if you were to graph this, okay, you would see something that looks sort of like this. You would see that the farthest left that this graph goes is 3, and then it continues to infinity. Now again, this is really kind of seeing how much you remember from last year. So if you remember the square root function, okay, it starts at that point that we put. It actually touches it, so it would get a bracket. Algebraically, this is actually what we're going to do next class. We would take what's under the square root and make it greater than or equal to 0. Now again, we're not quite at that point yet, and that's what we'll do next class, but trying to get you ready so you remember. All right, so the rest of this video actually, guys, is going to be reviewing Algebra 1, just plugging things into functions and then looking at linear functions. So when we talk about functions, it's important that we understand notation, okay? What are x values and what are y values? So on this first one, it says to evaluate the function at each value. So it gives us the function g of x. It wants to know what g of 0 is. What that notation means, it's read g of 0. This means when x equals 0, then what does our y, or what does the g of x actually give us? So this means plug in 0 for x. So this is just 7 minus 3 times 0, which is pretty easy. That's 4. All right, same thing on the next one. I would plug in 7 over 3 for x. So 7 minus 3 times 7 over 3. Now, one thing I will encourage you guys to do, and talk about this a lot in class, please do not use a calculator on these types of problems. I know you have one there for backup, and that's fine to double check, but we really need to get in the habit of using our not using our calculator to do fraction math, because fractions are going to come up a lot this year. All right, so this would be 7 minus 7 thirds times 3 would be 7, and 7 minus 7 is 0. All right, looking at the next problem, again, trying to evaluate these, it says to find the x values such that f of x equals 0. So this is basically saying your y is equal to 0. What's your x? So we're going to replace f of x with 0. So 0 equals 15 minus 3x. Solve for x. So negative 15 equals negative 3x. X equals 5. Same thing on the other side, okay? Plug in 0 for f of x. Solve for x. So minus 1, divide by 5. And we want to leave this as a fraction. We prefer fractions to decimals, especially this year in pre-cal. You're going to see a lot of fractions. So just get ready and be comfortable with those fractions. All right, so going on from there, we're going to review some things about linear functions. So these are all the formulas that you probably saw in Algebra 1. Hopefully you remember a few of these. The ones that were probably the most common to you were slope and slope-intercept form. Point slope is one that's really helpful for us, and we're going to use it a lot today because it makes it really easy to write the equation of a line. Standard form you won't see as often, but it's good for us to have it on there. So the first thing we're going to do here, this was like a warm-up in class, so we're just going to find the slope of this line. So in order to find the slope, if it's a line, it's easiest to put it in slope-intercept form. So what I'm going to do is I'm going to solve for y. So to get y by itself, I'm going to subtract 5x from both sides. Then I'm going to divide by negative 3. And when you divide by negative 3, we're going to divide both terms. So this would become 5 thirds minus 2. Once you've solved for y, then it's easy to see your slope. The slope is 5/3. And a lot of people will say it's 5/3 x. Just remember the x isn't really part of the slope, okay? A slope is your rise over your run, your change in y's over your change in x's. We don't need to include the x. The x is just in the equation. All right, so if we want to find the slope between 2 points, then that's when we're going to probably want to use the slope formula. Now, if you want to, you could graph this and you can count the rise over the run. But if there's a big space between these points or you don't have graph paper, the formula is going to help us a lot. It doesn't matter which one's 1 and which one's 2, as long as you stay consistent. So I'm going to make this x1 and this y1. I'm going to make this x2 and y2. So we're going to do y2 minus y1 divided by x2 minus x1. So 7 minus 3 is negative 10. 3 minus negative 1 is 4. Reduce your fraction, and I get negative 5/2 as a slope. So that, again, that's our change in y's over change in x's, the rise over run. All right, once you know slope, it becomes very easy to write equations. So I want to write the equation of a line that goes through the 2 points that we just found, okay? It says to start in point slope form. Point slope form is a lot easier to use when you have a point and a slope. That's where it gets its name from. So the way we use this formula is we replace the variables that have the little ones on them. All right, so this is going to be y minus, and then y1 is going to get replaced with either y coordinate, okay? I could do either one. There's more than one correct answer here. I'll just use the first one. I'm going to use m as the slope that I just found in the previous question, because that's those same points. And then x minus x1. So the x coordinate that goes with the y coordinate that I picked. Okay, and that's the thing that's important. If you use the one y, make sure you use the other x. And now we're in point slope form. At this point then, it says define slope intercept form. So what I'm going to do is I'm going to solve for y. So I'm going to go ahead and distribute. I'm going to add 3. And I'm going to rewrite that to make that fraction easier to add. And I get my answer in slope-intercept form. So point slope and slope-intercept form, again, one's a little bit easier to use depending on the problem that you have. All right, so again, just reviewing a few other things from Algebra 1, horizontal and vertical lines. These are the easiest to write, but sometimes the hardest to remember. So I have a little acronym I learned at my old school. It's called HOIVUX, and it helps us remember about horizontal and vertical lines. H stands for horizontal. The O stands for zero slope. Horizontal lines have zero slope, and they're y equals lines. So if I want the horizontal line that goes through the point 710, that point would be y equals, because horizontal are y equals, and what the y coordinate actually equals is 10. If I wanted the vertical line, it would be x equals 7. All right, so speaking of vertical lines, the VUX stands for vertical. The U stands for undefined slope. And the X stands for x equals lines. So if I want to write the equation of a line with an undefined slope, that is a vertical line. Vertical lines are x equals lines, and what x actually equals here is 3. Okay, so horizontal lines, zero slope and y equals. Vertical lines, undefined slope, and x equals. All right, so I know it's kind of a lot today, but hopefully most of this is review for you guys. So we're going to go on to parallel and perpendicular lines. So some other things hopefully you remember from Algebra 1. Parallel lines have the same slope. Perpendicular lines have what are called, the fancy term is negative reciprocals. The easy way to remember it is flipping opposites. So what you do is you change the plus and minus and you flip the fraction, and that's how you find a perpendicular slope. All right, so it says write the equation of a line in point slope form. So I'm going to rewrite that. So that's our point slope formula. All All right, so we want to write the equation of a line that is parallel to this line. So if it's parallel, it has the same slope. All right, and then this is my x, this is my y. So y minus 5 equals 2/3. I don't know why I wrote x1. X minus -4, which is x plus 4. And since it says point slope form, I can stop there. I don't need to do the extra work. All right, now we're going to find one that's perpendicular. So a perpendicular slope, I flip the fraction, and it's the opposite sign. So -3/2 would be my perpendicular slope. So same formula, y minus y1, so y minus -7, so y plus 7, equals -3/2, x minus x1. And again, we don't need to multiply it out because it says to use point slope. Well, actually, it didn't say what form to use. So if you want to multiply it out, you can. But I'm going to use point slope because it's a little bit easier. All right, so then intercepts. Okay, so x-intercepts and y-intercepts. Yes, you can find these on your calculator, but it's important to understand what these things mean. Okay, and in this case, if you were to use a calculator, make sure you solve for y. But the x-intercept is what occurs when y is 0. The y-intercept is when x is 0. So if you want to find these algebraically, okay, what I would do for the x-intercept is I would plug in 0 for y. So I would do 0 minus 3 equals 1/4, and I'll go ahead and multiply that out. So 1/4 x plus 1/2. So then I'll subtract that 1/2. So that's -7/2. Multiply both sides by 4. And that gives me my x-intercept. What I'm also going to do is I'm going to write my x-intercept as an ordered pair. So that's really important that we get in that habit. All right, so now we'll do the y-intercept. So to find the y-intercept, you can either write it in slope-intercept form, because you guys know in this form, the b is the y-intercept. But currently, we're not in that form. So the other way you could do this, the y-intercept occurs when x is 0. So I'm going to plug in 0 for x. So this gives me 1/4 times 2 is 1/2. Add 3. And again, I'm going to write it as an ordered pair. X is 0, y is 7/2. All right, so our last thing for today, we're going to get to, we're going to graph this line. In order to graph this line, though, again, I'm going to go ahead and solve for y. If you want to just pick a bunch of points, you can, but that's a lot harder. So to get y by itself, I'm going to subtract 2x. I'm going to divide by -3. Oops, that should be positive. And then I'm going to graph this line. So this means that the slope is 2/3, and the y-intercept is -2. So I'm going to go to -2, and from that point, I'm going to go up 2 over 3, up 2 over 3, up 2, and you just keep going until I get enough points to really get a good line. And I'm done. All right, so hopefully a lot of this is review from at some point. I know it may be a little rusty, and that's okay. That's why we're practicing and reviewing. But if you have questions, please feel free to ask in class or stop by in tutoring.